We begin by listing all orbitals in order of increasing energy. Each orbital can be identified by the principal quantum number, followed by the letter S, P, D, or F, and a superscript that corresponds to the number of electrons that occupy that orbital. We can represent the orbitals with letters and numbers or with boxes. When using letters, it is possible to write degenerate orbitals, such as the p orbitals, as px, py, and pz. However, more commonly, they are written only as p. According to Pauli's exclusion principle, a maximum of 2 electrons with opposite spin can occupy each orbital. When using the boxes, electrons with opposite spins are represented by arrows in opposite directions. Here is a list of orbitals with increasing energy. Note the inversion of the principal quantum number between the 4s and the 3d orbitals. As an example, let's write the electronic configuration of lithium. The first rule is the Aufbau. Electrons fill atomic orbitals in order, from lowest energy to highest. Lithium has 3 electrons. We can place 2 in the lowest energy orbital, the 1s. The next orbital is the 2s, where we can place the third electron. We can also write the electronic configuration of lithium using letters and numbers. If we want to write the electron configuration of atoms with more than 4 electrons, we need to fill the degenerate orbitals such as the p orbitals. To do this, we need a new rule. Hund's rule states that every orbital in a subshell is singly occupied with 1 electron before any one orbital is doubly occupied. Also, all electrons in a singly occupied orbital have the same spin. For example, if we need to fill the 2p orbitals, we need to place 1 electron with spin up in each orbital before we can double fill them with spin down electrons. Let's write the electronic configuration of oxygen with 8 electrons. The first 4 electrons will fill the s orbitals. When we fill the p orbitals, we need to apply Hund's rule. Of course, Hund's rule will not make a difference if we write the electron configuration with letters. The same principle will apply when we write the electron configuration of atoms that fill the d orbitals. Let's write the electron configuration of manganese with 25 electrons. We start filling the orbitals from the 1s and going up. When filling the 3d orbitals, we will apply Hund's rule.